Hi, great. Hopefully that went all right for everybody. In the last, especially in the last probably year, as Convex got more popular, we've had a lot of experience answering Discord questions about things people can run into, confusions that can come up when you're using Convex. And of course, a lot of these are just the JavaScript is hard, right? Or that web development, there's a lot of parts to it. But there are some things. So I'll try to point some of those out as we're going. And then I don't want to set expectations too high. We'll see how many of these we get through. If you're just joining us, right, this is starting out by just all that we did was, I'm going to kill it for a sec. All we did was clone this repo, go in there, run npm install, and then npm run dev. And that got us this whole site here, which, looks kind of mobile, I suppose, but this thing, we can have multiple of them. We can have them chat with each other. And the one thing we accomplished before was in a Convex query, you can read things from the database, but you can also do arbitrary data transformations to those. You can use any NPM library you want to change those in any way. So here, all that we did was say every time we see a colon and a closed paren, right, little smiley, replace that with a smiley emoji. And let's look at the code for that. We did that. It was this, not on the front end, it was in the back end in messages here. We said, great, replace, do all these. Okay, so that was number one. That was our example that we did right away. What's next? How would you impose a character limit? So, right, we could do this in the right path and just reject messages that are over that limit, or we could truncate them. I think a better user experience would be to reject them and then also add client-side validation to check that they're not too long. So first, let's get the server side working, because it'll be easier to test before we have the client-side validation. In this insert message code, I'm going to say if body.length is what's a reasonable character? What's Twitter's character limit? 160 or something? Let's use something smaller. Really, over 50 characters is probably too much. Then throw new error. So this is actually going to, if I throw an error on the convex side, let's see. Actually, let's throw a convex error so that we could even pass a message back. Convex error. No, what should we say? So if it's not a convex error, then when we run this in production, on the client side, they won't be able to see a stack trace. They won't be able to see, and they won't be able to see a stack trace here either, but they won't be able to see what the error was, because a lot of times you don't want to reveal that to your users, right? You just want to say, hey, server error, and you want to be alerted. Whoa, there's an error. You go fix it. But if it's an expected error like this, we can use a convex error to pass that data back. So let's say message too long. Okay, and if I save that, now back in our app, I try to send, this is a long message with more than 50 characters. How do I know that? I'll just run my finger over the number thing 5 times. Okay. All right, I hit enter, and it's hard to, or actually maybe it doesn't work. Okay, I hit this thing, and just nothing has happened. So probably, yep, that's because we're throwing errors. So, and it says, uncaught convex error, message too long. Great, but let's cope with that on the front end. So in our code here, we have our input. When it changes, right, we do the message text stuff. On submit, wait for the new message to come back, and then set new message text to empty. If that's good. If there's an error, we don't clear it. I think that's good behavior. But I do want to say, hey, try to do this. Catch that error. I know it's probably going to be a convex error. And convex errors, let's see. I'm going to just say, you know what? Well, I don't know that it'll be a convex error. So let's check to see if it is. Let's read the docs on convex errors. well, that's the API docs, but I want to read. Well, I can read that. That's fine. It's an error. It's got a thing called data. So let's just say if there's a data in that error, then go ahead and we kind of need an error state now, right? So let's say set error to, I know it doesn't exist yet. Set error to, I know it doesn't exist. Set error to e.data. I think there's the e.message will be fine. Oh, I see, but all it proves is that it has data. Great. I think there's also a message on it, isn't there? Maybe not. Maybe it's d dot. Maybe there's. I think that'll always have a message. What's the right way to go about this? I bet we have a example. Convex docs. Nope. Sorry, convex error. Nope. Convex error. Here we go. Error handling. What is expected when we do this? Application errors. We throw an error, and then when we handle it on the client, okay, we can check if it's an instant. That's nice. So error message is if that error object is an instance of a convex error, then let's get this out. Convex error. Then we should be able to say e.data, and we'll know that that's what it is. Otherwise, it can be unexpected. And this is what I'm going to set. Say set error to be this error message. And then we better clear that when we do a successful send here. Great, we'll do that. And then let's put that in here. So cool. And now I need some error. I'm checking Discord if anyone has specific questions that we can hop to. Like, well, sure, use state. We'll say this is going to be, it's a string or it's undefined. Cool. We got to display it somewhere. Just put it right above the input, I suppose, right above our form. Let's do error. Yeah, I think just error will work because when it's undefined, we won't see anything. Okay, let's take a look. When we send something, I'm going to type it all out again. Hopefully that's too long. When we send it, we get message too long. Great. It looks like we're not coping with it yet, though. I'll leave these on in case, just to prep in case people say things. Okay. We are doing that. Try, await this, otherwise catch it. Let's see if that's happening. Okay, Convex messages 21. Okay, that's expected that would happen there. But then in here is where we're doing it, right? Are there any other? Find send message. Yep. Send, that's the one throwing the error. Here's where we're catching it. Looks good to me. Let me make sure our code's reloading. Yep. Okay. We've got our server error. Try the send message. Make sure that this is the code that's running. That's the debugging step I like to do. Hop back. That's funny. Am I just looking at... Oh, I'm not. I'm just looking at errors, it looks like. Is that because my filters here are set funny? Okay, before, after, caught an error message. Great. Okay. Cool. Great. We set error here. I'm going to say on a clean one, let's clear the error. Set error. And where are we rendering this error? Right here. We can put it in the form. Maybe that would. Maybe we'll see it there. Form on submit. Some text right in here. There's some formatting so that it's not showing up. If I check out my DOM, I'm going to see whether it's there or not. Form. Yeah, I don't see the error here. So it seems like, what was it called? Error and set error, yeah. In the catch, we're going to set error message. So task one, so far, much trickier than I anticipated. Caught error. Okay, our error message is undefined. That's interesting. The error we're getting here is not e.prevent default. Okay, on submit. And okay, we've got some different e's going on. That's interesting. Error. Let's be very clear. Talking about that error. Error. Okay. Okay, caught error message. Caught. The error message is if the event is an instance of convex error, then do this stuff, then say error.data, and we're expecting that error to have that message. Let's log that error. Console.error. Log error. See what it looks like. It is a convex error with all this stuff. Okay, well, let's pretty classic. Window is any dot my error equals the error. And let's look at that object. My error. gotta do this. Oh, my error lower. Great. Does that have properties? It has a data, and the data is message too long. So we were just looking too deep in here. It's always when you cast, that's when you run into problems. Great. Okay, now when I send this, error message too long, great. And then once I'm finally able to send one, that will clear. All right, so even better experience, right, would be let's have a live counter of that kind of stuff. But we're more about backend. So I'm saying we've successfully imposed our character limit. All right, how would we make old messages fade away in over time on the client side? So this is styling based on the current time. It sounds like a totally client-side thing because it happens we already have the data we would need here to do this. We have a creation time. So let's use that. On the client, I'm going to calculate an ago. Let's say message dot creation time. I'm going to do now minus that date. I want the a date like this. Let's see. Remind myself how this works by opening a console. Node date. Okay, that's no good. But this, that's not what I want either. But this, nope. Date.now is what I want. So initially, because it's the easier way to do it, let's just assume the client clock is right. And I can say date.now minus message.creation time. And then that's going to be in milliseconds. So, divide by 1,000, say seconds ago. Now, anytime you use date.now in a render function, we have to figure out what the behavior we want is. Let's take a look at how this works, though. Wow. Thousands of seconds ago. So we should use a library like Moment or something to turn this into something prettier, except that we're trying to make them fade away in the past, right? So let's say the opacity maybe of this message has to do with, okay, we're doing class names, going to just jump in and use some styles. Style equals opacity. Is that a thing? Style equals, I need one more of these. Opacity, I think it's a number between 1 and 0. So let's just say this thing, how about math.max of 0 of 1, and this thing math.min, sorry, min of this, and the math.max of 0 and this, so I don't have to worry about messing up here. Let's just take that number and yeah, I divide by 10 or something, right? So it fades out. After 10 seconds, we shouldn't be able to see it at all. Let's see if I'm doing that correctly. Let's put that number somewhere too. So once I'm trying to do something like this immediately returning map is a little frustrating. So let's go ahead and open it up, and so I can have some variables in there. Return this article. There we go. Then after the return, we'll need to close this. Great. Let's call a const ago. Could be, this is our time ago, right? This bit here. And I'm trying to get a number between 0 and 1. So let's take that number, take a go, divide by, could be 100. That's fine. And then just make sure that it's within our range. Again, I think that, but the advantage is now we can log that. Const opacity equals this. Great. And I can also just render that in here. What's this look like? Okay, so we have numbers like 100 and lots of 1. What if I send a new message now? Still 1. Let's look at our math more carefully. I want the smaller of a go and this thing, the larger of, let's look at a go. Let's do our, let's turn it into seconds right here. Great. Okay. It's just backwards. So let's do 1 minus this. Great. Look, they fade away. Okay. Not a great experience. We can see a new message. It's very clear. But it's a totally client thing because we have enough information here to do it. I don't like this. Opacity 1 all the time. That's the only appropriate thing here. All right, next. This rate, we're not going to finish these. So it'd be, if you have a particular one you'd like to see, let me know. Let's talk through a few. How would you make old messages fade away? That we just did this. How would you make messages be deleted after a certain amount of time? So this is a server-side thing, right? Every time you send a new message, I would like there to be something scheduled to delete that message at some point in the future. First thing I would do is look up in our docs, scheduling. How does that work? Scheduled functions. Looks like when you're in a mutation, you can just say, hey, after this amount of time, please run another mutation or this one if you want to recur. So let's do that. So every time that you send something, after you insert that into the database, let's context.scheduler.run after 5 seconds for now. For testing, it's always nice to use small numbers, right? And let's do this is a function we need to write still. Export. Now I don't want anyone to be able to delete message. It's just me. So I'm going to say export const delete equals, or delete message. How about just so it's not a keyword. Mutation. But let's use an internal mutation because this is a private thing. This isn't something anyone should be able to call, unlike this, which is a public function. Internal mutation of, oops. And I don't really need an arg validator. I can just say, hey, handler, I wish that we could convex.db, whatever the passed in ID was. I better use a validator so I can make sure. Args, I'd like a v.id, and it's an ID of the messages table, please. Actually, it's an object where the ID is that. Let's have an ID, and let's say delete that ID. Cool. This will happen after 2 seconds. Delete message. The args are an ID, which turns out is the return value from an insert. Great. Delete message is not how we spell that. We say API or internal dot messages dot delete message. Cool. So now if I send something, I should see it, right? If I send a message now, That's an interesting React behavior, right? All these re-rendering here. If I send it, I should see it show up here. And then it was deleted. It went away. So Samantha says something. There it is. Boom. It's gone. Okay, great. And these next two, maybe we could skip because there's a very nice walkthrough at this link. If it is time for for questions or for discussion or anything. But we can also go through those, so depending on whatever Frontend Nation folks want to do. This tour of Convex is great. It walks through these next few exercises. So let's get started developing. I think it's about here where we get to, hey, I want to do the next thing, which is implement likes on messages. So to do likes on messages, we have to store those likes somewhere. So we're going to figure out how those work. So this could be a thing where it's just a count on a message, right? How liked it's been, and anybody can click that. But maybe it'd be better to say, no, a like this is not like a props thing. This is not like everybody gets to like something or not, right? I can't just sit there and click and have it liked by everybody if we're building a normal messaging kind of thing. So I need a data model that lets me represent that relationship. Let's look at our schema here and think about this. But feel free to, if anyone's watching, if front-end folks are watching, if Frontend Nation folks are watching and you want to do questions, that makes sense. Feel free to jump in. What could we do? Well, yeah, let's look at that schema. In our schema right now, we have a single table, and it's just this. We could add, hey, there's likes, and it's just a number. And then anyone can hit some UI to increase that number. But that's not, I think that's not the idea here, right? We would rather say, well, let's have a likes table. And the way that works is we have the ID. And that this message ID is which of these messages we're talking about. And then I need a user. I guess all we have is user names here, right? Just authors. So I guess I'll just store that string and we'll enforce that those are unique. That would be one way we could do this. And I'm tempted to go all the way and have a users table too. But if we're just doing likes, we could get away with this, right? We could say the message ID, right, is going to be a v.id of the users table. And we need a user so we know which one it was that did this. And we need some UI for liking something. So I think it's time for maybe a new table or a new file here. We could have a new file called likes. We can just put them in this file. Export const like. So when you like something, you need to say what message it is you're liking, and you need to say who you are. So anyone can do this. So it's a full mutation. Args are going to be, I need a message ID. And I need an author, who it is that's liking it. Yeah, that's the args. And then let's write a handler. Let's get the context on an args. And the thing we'll do here, why is everything so red? Like equals mutation of, handler, you're not supposed to call like that. It's just like this. There we go. got let's insert. For now, we won't enforce the uniqueness yet. We would say insert into the likes table a new like, and it's basically just what we sent. There's a message ID because that's what we had in our schema. And likes, message ID, and user. Great. And user. Cool. Gonna wait that. Was there? Oh, it's called author. Author. Let's call it user though. It's a better name. User. Great. Message ID. We've got that. It is it's supposed to be a user ID in our schema. That seems wrong. It's a message ID. Great. And here we go ahead and insert it. Make this an async function. Async. Great. Now we need some way to run this code. Now we could just build the UI, right? And that's what we should do here. But the Convex dashboard lets you just run functions like this. So I can just go into here. Let's pop up our dashboard and go look at functions. And we see in messages, there's a thing called like. And I could just run that function. So let's run it. Back in data, we could see, oops, made it too big. Back in messages, we see that, the one I'd like to like is about our most recent one, which was this ASDF. Let's say it said something nicer. Something nicer. Right. Let's find that app. Great. Something nicer. How could we add a like to that? Well, we can add the get that message ID, which we don't have here, but I can find right here. So let's copy that. That's our message ID, and our user was Regan. So when I run this mutation, it says it failed because the table of messages doesn't match the ID was not a message. Looks like it went to me. Did we not? Maybe we didn't get the full. Did we not copy the full thing here? Message ID is supposed to be this, and it's supposed to be an ID, match the table name, ID message. Here I called it message instead of messages. Great. Message ID is also supposed to be back to schema here. Messages, plural. Great. Great. Seems to have succeeded. And now I go look at my likes table, and there it is. So now, next thing I do, which I think we don't have time for, is we would modify the query function, because here we are getting a list of all our messages. It'd be fun if we included in that some lookup. So list here. After we get the messages, we could go look into the likes table and find out how many likes we have and then display them. Maybe we need to know each user who's liked it so we can show that in a little pop-up. And if you're interested in this, go check out this Convex tour, because it just walks you through a whole thing, exactly this task that we were just doing here. In Convex in your app, it says, hey, let's implement likes, like buttons. So if you want to see a more detailed one there. Cool. So we got to all but one, and this app, this tutorial, this tour here, walks you through all the rest of them. So, those last two of how to build a chat AI or an AI bot, and how to do those like the like modeling, which we did, and then the displaying of those likes. Cool. I think that's pretty much it. There's things I could talk about on Convex, and especially if there are questions, but the moral is it's not so different than building a normal backend. You just need to go through this extra step of, what is it that I'm doing in this function? Is it a mutation or is it a query? And the superpower you get for that is that you can subscribe your queries. Cool. think that's it.
Hey. That was very nice for the people who were interested yesterday into knowing more about Convex. Now they are all set up, I guess.
I hope so,
All
yeah.
quite happy. Thanks again for this, Tom. We have a few questions. Sorry? Yeah, we have a few questions.
Great.
Could you elaborate on the TypeScript, on the type safety that Convex provides?
Sure. I mean, there's a lot of it, right? Like, well, you just saw one part there. There's a place where it's hard to provide type safety on IDs in schema definitions, but otherwise, there's a lot of type safety. Can I share my screen for a moment?
Yeah, sure.
Great. So, I mean, the coolest part of the type safety, I think, is here I'm in my app, and I'm looking at a mutation. I can hold down the command key on a Mac. I think it's Control, other places, and look at that list, and I just hop to definition there. And that's not type safety, but that is a hint that there's an understanding that TypeScript or the IDE has of this. And that means in here, if I add a field called hello, which is always this number, and then when I hop back, I can hover over this, and it says, oh, by the way, it also returns hello, which is a number. Right? So it's this instant, this very powerful type safety that's very quick, right? I just change the way that my backend function works, and that data shows up on the front end. Similarly, when I change my schema, I can instantly, it'll tell me, oh, okay, we expect there to be this field, and I'll start getting errors that say, hey, when you're insert, you're not providing that field. So when you're okay, so I think that's it for screen sharing. But the it's a lot of type safety, right? You can, it's nothing that. It's kind of just a modern way to build apps, right? We just expect to have this type safety. If you're using JavaScript on the front end and JavaScript on the back end, you would hope that you could get this. Even if you're not using the same language everywhere, hopefully you're using generated APIs that provide this. But because it's all TypeScript, we don't need to generate these things. We just have that type safety, which is great.
Yeah, that's less work, less maintenance, less struggle.
Yeah, hopefully.
Thanks. Are there any common pitfalls that people need to look out when running queries?
Let's see. So one is that people will think, oh, I would like to, I want to call another service, right? I want to make a request to the server, and I'd like to get a list of all the messages I can see. And I also want to record somewhere in the database that view happened. Like, for example, I want to, I want my query to change the state of the database so it says whether I've viewed those things or not, right? Maybe a view state kind of thing. Anytime you're trying to write data in a query, that is not possible. These queries need to make no changes so that they're perfectly cacheable. They can't have side effects. And I think maybe it's the word query that makes that difficult, because we're used to a query being like, oh, it's a database query. Inserts are also database queries, right? But this is a different meaning of query, where it's a read-only query. It's the kind of query where you can only read data. So I think that's why it's that decomposition of saying, well, normally I'd have one endpoint that would do both of these things. And in Convex, it's saying, well, the benefit you get from splitting this into your read path and your write path separately is the caching you get on that read path, and the careful invalidation, if you need it, that coming from the read path. But you do need to split them out. So that's the common thing people run into.
Yeah, I'm not sure where I saw this pattern already, but I think that some other approaches also use this. Is it maybe gRPC or something? No, I'm not sure.
Yeah, TRPC and I think even well, yeah, TRPC definitely does this. Yeah, they call it exactly the same thing, I believe. Yeah, they don't have the same. No, I'm not sure if they do. I don't know that they have the same requirements that it actually, that a query actually can't read, but they use it for caching kinds of things, I think.
Yeah, and also it's easier than like having your own memorization and handling it yourself. And then when you have an issue, then it's like the worst part. Try to debug something when you have the cache, and then is it the cache, is it the code, is it something else?
Yeah. I think my favorite, I mean, the showiest thing about Convex is the live subscriptions, the live updating. But the thing I appreciate most is probably that perfect cache invalidation, right? Knowing that something is always up to date, which is related to live streaming, but it's and reactivity. But just knowing that, like, all right, the guarantees of the platform are to provide that caching. Yeah.
And as we said, you said that's always quite impressive when you have a subscription live and something's happening and looks
Totally.
sexy.
Yeah,
For
yeah.
sure. What's going on behind the scenes when you call mutation?
These are good. Whoever's writing these questions, this is just the stuff I want to talk about. Fantastic. So let's see. So going on behind the scenes. So it's some JavaScript that you previously sent to the server, right? So every time I change code in my editor, the Convex CLI is noticing that and then sending it up to the server, so it's up to date. And so when I actually call the mutation, it's just some JavaScript that's going to run. And it's going to run in a pretty straightforward way. We're just going to run it from top to bottom. But every time that we write to the database, we record that on the side. We say, oh, this thing wrote to the database, by the way. And that way, and when it writes to that database, we get to say, okay, if any queries that read from those same parts of the database, those need to be invalidated. Those need to rerun. So that's one piece. And then the other piece is that we do some, mutations are a transaction by default. So they can run from top to bottom and then say, oh no, in the time that I was running, somebody else changed out the data from under me. And that means it would be potentially inconsistent to commit my solution, because I could, the classic example of I have a counter and one mutation reads it, increments it, and goes to save it. But in the meantime, someone else has already read that value. So it would be overwritten by the second one. So you're doing all this careful noticing conflict. The things that you read. Yeah, the conflict resolution. Yeah. So that's the other thing going on under the covers, behind the scenes, is that we can run them multiple times. So you might run it and say, oops, there was a conflict. Great, run it again. And that's why it's important that those mutations don't do network calls. Because if you called Stripe in there, we can't, we can only do the things we have careful, we can only roll back those things we have careful control over, like the database.
Yeah, that's why Stripe has a dedupe there's very
yes
name.
So that's very cool, right? So for some APIs that have kind of idempotency keys or the dedupe kinds of things, right, we could get away with that. And I think we'd like to do that, but it'll have to be more controlled than just any fetch, right? And the other thing is speed. These mutations, if they conflict, we'd like to run it again, and potentially again and again and again and again. So we have a 1 second limit on how long they should take. And ideally, they should be like milliseconds to execute. And as soon as you start doing network calls and waiting for them, right, we're now into hundreds of milliseconds potentially. So that's another reason we don't want those network calls in there. I'm so excited, though, for, providing those idempotency keys for the few APIs that provide them, right, that allows us to do a lot more. Yeah, that's future stuff. But yeah, that'll be great.
Yeah, a lot of bright things upcoming. That's very nice.
Yeah.
I'm not sure if we have any more questions. Since it's the end of the conference, people are maybe tired.
I'm sure. Yeah.
But as usual, you're a very nice speaker, and your talk was very good. So
thanks
for this.
I appreciate it. Thank you.
You have a lot of energy, and you explain well. So I'm not sure if you're used of streaming while you code, but
I'd love to. It's really nice to hear you say that. Yeah. It's very fun to. Yeah, it's fun to get to talk to people. I do, my normal work is just sitting a lot, right, and write the code. But I think better, when I'm explaining things. So even that, not finding the error for 20 minutes, maybe I would have solved it faster on my own. But I certainly thought clearer by having to explain it to you all. So that was great. So thank you very much.
Next time we're going to put a live chat next to you, so that way you can come and interact with it. And we're going to call it Twitch.
Great. Perfect. Neat idea. That could go somewhere.
Yeah, I'm just proposing this idea because I have a few friends who did exactly that. So yeah.
Oh, cool. That's great.
Any last words since you're the last? You're gonna have like a golden rule of saying something nice or something.
Sure. Yeah. Well, that is good. Absolutely, a golden rule. I mean, yeah, absolutely, saying something nice and just good. Trying things is hard, and I think. This format today, I think, was really neat. And that's how I have to learn anymore, right? Like, I find it so hard to open a textbook. Textbooks are so cool. They contain the right information for the thing to learn. And then on the next page, they often have the next thing. But I just can't unlock that power unless I've tried to solve a problem. And I just have so much trouble caring about something I'm learning until I've wondered it myself, right? Until I've tried to do that thing and thought, oh, how do you do that? And now I'm very receptive. So if you think the way that I do, this exercise stuff is great. Go for it, right? Try it. Don't feel bad about trying to just do it. But then, I don't know, now you're ready to hear about it. Anyway, so I really like this pedagogical approach.
Yeah, I agree. Yeah, that's why the team thought about this, because otherwise, if you just read and you think, oh yeah, I think I know this, you will never like experience the issues that will make you improve. And some people think that if you fail and if you have bugs and if it doesn't work, then it's bad. But no, you're actually moving forward. So
Totally.
yeah.
Yeah. So thanks so much for the opportunity. Yeah, this was pretty cool.
You're very welcome. Anytime.